Welcome back to Getting Started with Python Programming for Data Science. In our previous lessons, we looked at what is a programming language, how we can use a programming language to give instruction to a computer or a machine, and then what are the uses of programming language, how we can make use of programming language to solve problems. Then we looked at how we can install Python as a programming language in your local computer, or how you can use Python in a cloud platform such as Google Colab. We also explored some IDE options where integrated development environments you can get help to start coding with Python. In this lesson, you will be looking at basic Python programming such as syntax, control structures, how you can use functions and classes to build your foundational knowledge about Python programming language in order to you to start learning advanced concepts. My name is Sumudhu Tenakon. I'm a data scientist. I will be helping you through this course to learn Python to get help for your data science and AI career. Previously, we looked at the concept of writing a program code and translating that human-readable programming code to a machine-readable machine code using translators such as compilers, interpreters, and assemblers. In this lesson, we will be exploring how we can write this program code actually. We have a number of options depending on the programming language you choose. In Python, you can write your program code as a notebook, which is having the extension IPYNP, or the traditional method of writing Python scripts with having .py extension. Python also provides the option of sending commands through terminal. You can simply type Python command and execute through terminal as well. But if you wanted to save your program code for future use, you have to either create a notebook or a Python script. Both will be useful in data science and AI applications, as well as many other applications you use Python. We also explored how you can give simple instruction to your computer with an example. I'm going to review this for everyone's benefit in this lesson. So our task was to find average of given set of numbers. We assumed those numbers were stored in a file. What are the steps we need to proceed in order to get this task done? So first we need to read the file and extract the numbers, and then we need to count how many numbers are there. After that, we need to add those numbers together to find the total value. And then we have to calculate the average by dividing the total value by the count. Once you calculate the average, user don't know what is the result a computer generated. So you need to display the result. So that's the last step. So you should be able to see the result on a computer screen after this step executed. Then we convert it into a pseudocode. How we can convert this to a program code. This is not Python yet. This is like a code you can write as a pseudocode. You can translate into another programming language. So we explored this option in detail, and we also did the computation, and then we found out the answer is 14 for this problem. As human, when we want to communicate with each other, we use a language. To use a language effectively, you need to know the language, the vocabulary of that language, some rules such as grammar, and what are the sentence structures, how you can understand different words like that. So to effectively communicate with a computer, you need to know better about a programming language. What are the building blocks of a computer program or a programming language? Providing input, the way to provide input, how to retrieve output are very important, because those are the things will be helpful for you to interface with a computer, and how we can use the programming language vocabulary of that programming language, how you can understand it by keywords, data types, operators, and special symbols, how you can define a variable, how we can define a constant, what are the expressions and statements, how the statements are made to give instruction to a computer, and what are the scope of the variable and other objects within the program code. Those are very important things. In our lesson, part 1, we will be covering those topics. In the next lesson, we will be covering data structures, conditions, and loops. And the last part of this section, we will be covering functions, classes, and objects. So the data types is also very important to have that understanding. Data types can be divided into several categories: numeric, text, logical, other data types. So some programming languages, they create data types as objects, such as Python. So all data types in Python considered as object data type. That's a superclass. But you can have like a separate subclasses like numeric data types like integer, float, and complex numbers also you can represent it by a separate data type depending on the programming language you use. And then the text data type. Text is represented by either single character or multiple characters. So multiple characters are called strings, single character, the character variable. But in like languages like Python, you don't have like a separate single character variable. Both single character and multiple characters we consider as string in Python. But some programming languages, you can define single character and variables as a different data type and strings as a different data type. Right? And the logical data types, either those are like we call Boolean. Boolean can take only two values, true or false. So it definitely is a binary variable that's we will be creating with a Boolean. That's obvious. And the other data types we can call files, images, videos, sounds, any other thing you store as a data type in that programming language defined to you, so you can consider as others. So this is kind of a hierarchy. So what we have in terms of data types in very high level, but depending on the programming language you use, you have like a proper definition of each data type. Right? This is for your general understanding. Few things I wanted to have like have a deep understanding on data and data analytics and machine learning, model building, or anything related to data science work. So you should know whether the data can exist or not for a specific data field. So we wanted to define what is the representation of nothing. If the data don't exist, what is the representation? Depending on the source you receive data, they could have like a different representation for nothing, right? Some people put negative 99 to say, okay, we don't have that relevant data. So if you find like in an age column, all in a sudden we have like a negative 99. So that means you have to first need to consult the person who sent you the data, or the any source you need to refer any documentation. What this negative 99 mean? It could be a simple error. It could be a meaningful thing to indicate we don't have a record of this person's age, right? But in Python, we use none to represent nothing. And SQL or SQL, we call nothing. We represent nothing by like a keyword called null. Some programming languages we use void. So we have to have some way. We have to have understanding depending on the programming language, depending on the platform we use. What is the representation of nothing? It's very important. Pay attention to that. Sometimes in some platforms, empty string could be a representation of nothing. Okay, so the other data representation, numeric data can be represented as vectors, matrices, and tensors. We discussed these things in detail with the mathematics concepts. And vectors, matrices, and tensors also can be fall under a data type depending on the programming language you use. And the collections, collection could be sets, lists, tables, dictionaries. Could be we have like arrays in some programming languages, right? In Python we can create arrays or lists or sets, tables, dictionaries, different data structures to store your data. And the other structural representation, enumerators, structures, objects you can create. If you are using object-oriented programming language, Python, you can create objects. So you can also create. So they can fall under like a data type, or you can create your own data types for those. In this notebook, we will be exploring some basic features of Python programming language for anyone who is ready to get started with Python coding. If you are participating in the class, you will be receiving a link to download this notebook, or you can get it from the resources section. Here we are trying to cover the basic component or some of the building blocks we looked at in the previous slide. What are they? We will be exploring how you can create a comment in Python code, how you can get user input and print the output to screen, variables and data types, how you can define them, you can declare them, and how you can use them. We will be exploring how we can use string data in Python, and then how we can use numeric data in Python. As a data science workflow, in a data science workflow, data is a very important thing. Knowing how you can effectively handle in a programming language you choose, in this case Python, will be very helpful for your future work. Not only data is helpful, you need to operate on data. So you need to know what are the operations, arithmetic operators, logical operators, some conditional operators, some many other operators you need to apply on your data in order to get some tasks done. So at last, we will learn about them in this notebook. First, let's look at the comments. How you can define a comment or how you can create a comment in your Python code. So the line you can see here is a single line comment. So let's try to execute that and see what is the result. You don't see any output coming from the notebook. By the way, I hope in our previous lesson we covered how you can use the notebook environment. I hope you all know if you type any Python code in a code cell you choose in a notebook, you will be seeing the output when you execute that cell. You can execute the cell either using the run button. You can press this run button while you are focusing on the cell you wanted to execute, or you can hit shift plus enter. Okay, so we executed this cell, but we don't see any output. So not all cells will return you an output unless you print something or you're creating some variable which will return an output. But in this case, we should not expect, because this is a comment. The comments don't meant to return any output or to do any meaningful change to your program execution. They are just to give some messages to a reader who is reading this code, or to yourself who, if you are the coder, you need to read this code in a later time. Sometimes it will be useful to debug. Sometimes it will be useful to know what this function does, what is this variable is created for. So those things you need to communicate either with yourself or someone in your team or someone who is reading this code in the future. If you are participating in any open source initiative or participating a project which is going to be open source, or it's already in open source, you're contributing to it, make sure you provide valuable comments and meaningful comments appropriately. Therefore, the comments are very important. So we know now how we can provide a single line comment. So the notation is, or the syntax is, put the hash sign symbol before the text, so we'll make it a comment. So nothing after the hash symbol will be executed in that line. If you want to provide a multi-line comment in your code, you have three different ways. The first way is using triple quotes. Between these two triple quotes line, you can write anything in between. So those will be commented. The entire line, even you don't have hash symbol, all these lines will be commented. And also you can use single quotes as like a triple quotes. This also considered as multi-line comments. You can use multiple single line comments in order to create a multi-line comment. These are three different ways you can make comments in a Python program code. We can execute this. You will not see an output ideally, but in this case, in a notebook, if you type something like in as a string form, so in this triple quote type thing, you will probably see output like this. But in a programming code, if you execute in a Python interpreter, you won't see anything. Let's go to the second point. How you can get user input and to Python screen and to print to screen. First, let's look at how you can print something in Python. Here, how you can print hello universe. The syntax for the print statement is you have to use the function print. It's a built-in function in Python. You have to provide the string you wanted to print within parentheses, same as you call any other function. If you previously know about functions, this will be helpful. But if you are new to programming language, if you are learning Python as your first programming language, don't worry, we will be covering these things in the future lessons. If you wanted to print multiple things as multiple lines in your same code, you can have multiple print statements. The same thing you can print into two lines by executing two print statements. The first line will print hello, the second line will print a universe. You will see the output right below the code cell we executed. Okay, let's go to like some complicated print statements. Previously, we printed these two lines by executing two print statements, executing the print function twice. We can also do this in a one execution of a print statement. What we need to do is we need to use some special characters. There are multiple special characters you can use in your print statement in order to format your string. So one is a tab character. Will leave a tab between the string. You wanted to have the space, you need to place the tab character between the location in your string. Or you can use the new line character /n. Will make a new line or line break to your string. In this string, we will be having a line break between hello and universe. Let's see what it is going to print. It print hello universe has two lines, but you're executing one print statement. So let's do the same thing with tab. So if you wanted to print a table or tab separated values in onto the screen, so let's see what it is going to print. So in this example, so we have the first word ID and then the tab character. So we'll leave a tab space between the next word f name, and then we have another tab character L name and another tab character age. So now you see this looks like a table header. So then the next line we are going to print the table values. The first value is 101, and then we can say the tab character name, tab character, the second last name, and the tab character and age. There will be a third line. Here I'm going to make a correction. Here I'm making it 102 because we have our first line ID is 101. We don't need to duplicate that ID. It's a different thing and not related to the print, but let's make it correct. So let's see what is going to print here. We have a nicely formatted table by using a tab character in your print statement. So this is a useful thing if you wanted to print a table onto your screen. You probably can use this tab character with your print statement. You can also combine this with a new line character. You can have everything in one line as a one print statement, and you can have a new line after each line you print. It's up to you. You can try that out in your own. So now next let's see how we can modify end of the line. You noticed when we print something using a print function, it always print on a line, and if you execute another print function, it will be printed on the next line. You cannot print with the default parameters. You cannot print two words or two strings on the same line by executing two print statements or to executing print function twice. Reason is every time when you execute print function at the string you provided, it will automatically add a new line character at the end. Let's see how you can modify that behavior. You can provide the function the function with a parameter end to your print function. You can provide any end character. So here in this line I'm going to provide end character as an empty character. What should we expect? We should expect there will be no new line character printed. after printing hello on the screen. And then I'm going to execute another print statement, another print function. Here I'm going to explicitly provide my end character is new line character. Remember, if you even don't provide this, the new line character will be your end line character by default. After we execute these two lines, the third print statement will execute again and say, let's learn Python. And then the end character will be a period or the dot. By now, you should understand the behavior of these three print statements and how the print output should look like. You can imagine that. Let's see your imagination is correct. As we expected, after printing hello, there won't be a new line character. Therefore, the universe, the second print statement, printed on the same line. But with a new line at the end of the second print statement, your next print statement started in the next line. And end of the third line or the third print statement, you see a period at the end of the line. All right, so let's look at how we can print multiple values in same print line. Okay, there's a typo. I will correct this at this point. All right, so in this example, you're going to print multiple strings on the same print function. So you can provide multiple strings separated by comma. At the end of the execution, or when it executes, all the strings you provided into print function will be concatenated with a space in between each string. We can verify that. So in the first line, we will provide ID, fname, lname, age as we provided in the previous print statement. Our intention was to generate a table out of it. But let's see what we are going to get here. The second line, we are printing the ID, name, first name, last name, and the age. So let's see what these two statements will print for you. It won't keep the tab separator and a nice table formatting, but it will print two lines. But you will notice all the strings, you don't have a space in any of these strings. But when it concatenate two strings in the print statement, it will add a space in between. Therefore, you can print multiple strings by comma separating them within the print function. Let's look at how we can modify this separator. Same as the new line character or end character we explored previously, you can make this you can modify the separator between each print argument, right? So you can provide multiple strings to print statement, and if you wanted to have the separator as the tab character instead of a space, you can pass the parameter separator or SEP, and then you can assign the character you want. If you wanted to make it a tab spaced character as your separator, you will get like the table format like we get previously. I hope you know what to expect here. So let's try to execute and verify. We get the thing as we expected, nicely formatted table structure, because the separator between each string you provided to print function is tab character. You can provide any character. I'm going to add a new code block or code cell and then try to make a different separator. So I'm going to put a dash. Right? You see what is the behavior now. You have ID dash. So instead of tab or space, now this the separator character is dash between each string you provided to print function. All right, by now you understand how we can use the print function with different behaviors you can expect from it due to the input parameters or the input strings you provide. So let's see another thing. We already looked at how we can print an output to screen. Let's look at how you can provide an input to the computer or to use in your computer program to process something. In most of the computing applications, you have to provide input, right? Think of a calculator you used, and also the example we discussed previously on the slide. You wanted to add some numbers, so you have to input the numbers you wanted to add to your calculator, and you have to provide what operations you need to do, etc. So those inputs you need to provide to the computer by using input methods. In notebook environment, you can provide your user input to the program by calling the input function. Input also a built-in Python function, same as the print. In the input function, you can pass a parameter which is a string, and you can give a user a prompt. If you are expecting an input from the user, you need to ask, what do you expect? You can give some hint, or you can explicitly say what do you expect, right? In this case, we expect name from the user. So therefore, we will ask, what is your name? And when the user provides this input, the input value, you need to type the value will be assigned to a Python variable name. We will look at variable in the next section number 3, but assume the variable is something you're going to hold a value temporarily. When the user provides their name, then we are trying to print the name back by adding hello before the name. We just need to greet that person. So let's see how it works. Let's try to execute this code cell. As we expected, the prompt asks, what is your name? I'm going to provide name. John is the name. And then I will press enter to execute. And then the next statement, the print statement, will say hello and add the name we input previously. So it says hello John. This is how you can get user input to the program in a very simple way. All right, so now let's look at how we can use variable concept in Python programming. Previously, with the user input prompt, you were using a variable called name. Let's explicitly understand what is variable and how you can declare a variable and how you can assign value to that variable. Before we start with variable declaration, you need to know a few things about the variable names you can take. I will first go to the bottom section of this notebook. You have to understand that Python is an object-oriented programming language, and everything in Python is an object. Therefore, we can treat everything as object, including variables, functions, everything. Python object naming convention uses rules and convention both. The rules, you must follow those. You cannot avoid for any reason. But conventions, you can have different choices. You can choose your own convention. You can continue using it. What are the basic rules? Every variable name must start with a letter or underscore. You cannot have a variable name or function name or any object name start with a number or any other character than an alphabet character or underscore. Only alphanumeric characters and underscores are allowed in your variable. So those alphanumeric characters including numbers. Remember, numbers cannot be the first character, but it can be any character after the first character in a variable name. You cannot use any other symbol in any place of the variable name. Variables are case sensitive. Some programming languages, if you're familiar with some other programming language, probably you're familiar with the programming language it's also case sensitive in the variable or object naming rules, but some programming languages does not. For example, SQL is not case sensitive. In here, like the name, if you have the first letter capital, the rest of the letters are simple case. So they are it is different from the name all caps form, and also it's different from name all simple case letters. So you have like 4 different representation of the same thing on this line. So name will be represented differently. So if you declare these variables, all 4 variables, there will be 4 different variables. Even they use same letters as a human can read. The lesson is they are case sensitive. The conventions of a variable creation or function name will be this. You should never use simple L. Even you can see the confusion what is happening in this on the screen as well. So you should never use simple L and capital I or O character alone to declare a variable or a function or any Python object. You can use them as any place of the variable, or you can have like a mix of those characters with other characters. But you have to understand always the L and capital I and O, sometimes you get confused with other characters, right? Example names as a suggestion. You can have like a simple case character. You can have a variable with one character. And you can have a variable if you have multiple words in your variable. You can separate them by underscore. You can have all variable characters, all characters in the variable name can be simple case or small case. You can have all characters in your variable be uppercase. But by the convention, we use this format, or the all characters uppercase, to define constants, not really variables, which can change during your program execution. Same thing you can do for function. If you have like a function defined with 2 words to define that function, you can separate each word by the underscore. There's another way you can do this, like you can have like one character, the first character of each word is capital. So this way we are using this method to define Python classes. Each character of word in Python class definitions are capital. You can also define a variable without underscore. There's no rule you have to have underscore between 2 words in a variable name. You can have any variable name. Those variable name can be meaningful, may not be meaningful. Like the last one, my package. This method we will be using as a convention, without an underscore method we will be using to give names to Python packages. Alright, so enough about the variable name convention. You can read more about them in internet resources. Let's look at some of the reserved words Python use. You cannot use them as variable name in any case. These are the words you can also see from the Python documentation. You can see like false, none, true, and like the list of words you can see on the screen. You cannot define them as a variable, or you cannot use them as variable names or function names or class names by any means. That's another tricky part in Python. There are built-in functions such as the input, print, and you will learn few more built-in functions later, but I will mention this again at that time. Keep that in mind. Those function names are not prohibited for you to use as your variable name or function name or class name. You will not get a warning, you will not get an error if you use them. But if you use them, you will be messing up with your programming code. You will not be you expected to run a built-in function, but you accidentally override the built-in function. You will be not getting the output as you expected. So those things you need to watch out when you are creating those variables. That's why you need to have you have to build your vocabulary to understand what are the keywords, reserved words, what are the built-in functions used in Python programming language. All right, so let's look at how we can declare a variable. Many programming languages require you to declare a variable with a data type, or define a variable with a data type. You have to say whether this variable is integer, floating point number, string, or any other data type. We looked at the data type definitions, or what are the data types in the slides previously. So if you need a refresh, you can pause this video now. You can go back to the slides section and review your understanding about the data types. So in this case, we define a variable a as 1. In Python, we don't need to define a data type. You can Simply create the variable as variable name and assign a value directly. The second variable we create, b, is 3.14. By now you should understand your first variable on this code cell you have is an integer. The second variable we created as a floating point number. Let's see what they are going to print if we print them in print statement. Again, you can print a variable value by passing that value into print statement. Like here, print within parentheses, you pass the parameter print string as a, and the second print statement you pass b. So then the both will print the variable values in two separate lines because you execute two print statements. If you want to define multiple variables on the same line, if you don't want to have like multiple lines to define or declare multiple variables, you can do it on the same line as well. You just need to have variable names comma separated, and the respective values also should be comma separated, as you see on this code cell. The first variable a assigned 2, second variable b will get assigned 1.68. You can also see what is printed here. So 2 and 1.68 is printed here as we expected. Okay, so let's look at variable data types. Okay, this is going to freak out many of you familiar with some other programming language. If you know Python, if you use a programming language similar to Python, you're probably not surprised about this. What happened here? We first created a as a variable integer data type, right? So a assigned as 3. Secondly, we assign 3.14, which is a floating point number. So integer variable got assigned floating point number, and then at the second attempt in line 4 of this code cell, a become a floating point variable, which was integer variable before, right? So the lesson here is the Python variables, and you can change the data type of that variable. You can reassign a different value from a different data type to that variable later. This is another place you wanted to watch out while you are coding. You have to make sure you are tracking the variable correct, and when you are assigning values to a variable, or when you are returning some values from another execution or another operator, with another operator you get like a value into the same variable, you probably will assign a wrong value, but you need to watch out for this data type conversions. It will not throw any error, or it will not warn you about this assignment. All right. Another important thing you should understand is variables are data objects too. Like I mentioned earlier, everything in Python considered as an object, including functions, are objects. So this c is an integer variable, as you can already understand. Like 12 is an integer. You can convert this integer value into byte string. So we know why I'm bringing this up now. So if you are familiar with object-oriented concepts, object is something you see an object in the physical sense, like a car. So if you consider car as an object, car can have a color, which are attributes. We call them attributes. It has a color, brand. Car can have a name, and it can have like how many seats in the car, like different characteristics. We call them as attributes. Car can also have functions such as change the gear or increase speed, drive, many things, many functions, right? So whenever we call those functions, car can do certain task or give us something out. So those are the we call objects in object-oriented concept in very high level. I just gave you the idea if you are not familiar with it. But here the c is a variable object or integer object. You can see it has a method called 2bytes. So what this 2bytes method does is it will convert this integer into a byte string. This is just to demonstrate how a variable considered as object. If you don't understand it, we will come back to this in a later time. So here your variable 12 is simply converted into a byte stream here. a byte string here with a little endian notation, right, with a 4 with size is 4. The second demonstration I wanted to show you, like for a floating point number. If you have a floating point number, there are functions. You don't need to pass any parameters into this function. If the a is a floating point number, you assign 2.0, that is why it becomes floating point number. We can call a function name is integer belong to that object. If this a variable hold an integer value, it will return true regardless of the decimal point. If not, it will return false. Let's see what it's going to return. It is true because 2 is an integer regardless of whether you provide an decimal point or not. Let's see what it's going to give when it is 2.1. It is false. So this is a useful function probably you can use in your data operations. So when you are doing Python coding, if you wanted to know a number, even you input that number as a floating point number, you want to know whether it's an integer or not. It's not an integer by definition in the program code, but the value represent an integer value, so that you can verify by calling is integer function. Okay, so here these two demonstrations are to show you or showcase variables, also objects. You can call attributes and methods in those variable objects. All right. So the other thing about variables, we already explored this concept. Variables are case sensitive in Python. So these three variables, names are different by the case, but they are having the same letter, 4 letters, right? So let's see what it will give you. As expected, they're considered as 3 different variables. You can print them, you can use them in anywhere in your code as 3 different variables. Even they use same letter, a human can understand. So now you know and you verified Python variables are case sensitive. All right, so now let's look at data types. As I mentioned earlier, we explored in a very detailed level what are the data types and what are the data types available in general, and also specific to Python programming language. We are going to explore that here, right? To find a data type of any Python variable, you can use another built-in function named type. A and B are like 2 variables we created above. If you wanted to explore what are the types of A and B, we can execute type A and type B. Let's see what is the output here. Both A and B now become floating point numbers because we know A and B both we created above. You can go up. A is now 2.1, which is a floating point number, and B we created above is a floating point number 3.14. So let's try to print the values for each and every variable here. Here A is an integer, we know that. B is a floating point number. C is a character. D is a string. E is a boolean. F is representation of nothing. We already explored this representation of nothing in our lesson. Different programming languages use different ways of representation of nothing, but in Python we use none to represent nothing in your variable, right? So one of the confusing thing that's who are familiar with other programming languages. In other programming languages, you use single character with this notation. Many programming languages use. And if you use double quotation, that will be considered as a string, right? So this will be considered as a string if you enclose A within double quotes. But in Python, there's no single character by definition. Everything, either single quote or double quote, will be considered as a string. Boolean, you can take either true or false values. So true and false, the T and F will be capital. So as you see on this cell. So now let's see, after we declaring each and every variable in different data types, and we can verify them. We can verify in a print statement what are the values of them, right? So now you can, if you execute, you will see you will know how to concatenate strings in the print statement with a comma separated, providing comma separated strings. And then we can verify the type of each variable, right? So let's execute and verify that. As we expected, it returned a is 1 and type of a is int, and b is float, c is a, and now you see you verified even you provide single quote, the Python recognized that as a string. D, as we expected, we recognize as a string. E is a boolean, F is none. The type is called none type. You will see this none type often in Python programming when you are working with the data and you are getting more familiar with the language. You will get this none type error. If you assign a none value to a place, you don't need to assign a none value. I'm talking as things you will expect ahead, but this is also something you will get familiar with the time. All right, so now let's see three more variable declarations. So G we define as true. We know true will be a boolean variable. If you provide a value true to a boolean variable, it will be a boolean, but here you're providing true as a string value. And then the H you're providing true as a value, like a boolean value. And K I'm providing, you know, this 3.14 is a floating point number, but I'm providing it as a string. So let's see what are the data types each of these variables belongs to. As we expected, this true provided as a string recognized as a string. True provided as true without quotes recognized as a boolean variable. And 3.14, even the 3.14 is a numeric representation, but you provided to Python as a string. It recognized as a string. So that K become a string variable now. You cannot operate numbers with this K variable even you have a numeric representation. All right. Later we will learn how we can convert this string representation of numbers, how you can convert them back to numbers, as well as you can convert numeric representation into string values. Sometimes we need to do that. So we will learn this in this notebook in very short time. All right. So now let's look at another important thing about representing different number systems. Most of you are familiar with decimal number system, and I know some of you are familiar with binary. You should be, because computers are using binary number systems, right, in the lowest level of operations. And also there are other number systems such as octal, hexadecimal, right? Binary can have like only two different digits, 1 or 0. Octal numbers can have 0 to 7 digits. Hexadecimal you can have 0 to 9 number digits, as well as A to F letter digits. So you'll have altogether 16 different digits in hexadecimal. The familiar decimal, we have digits like 0 to 9, 10 digits. All right. So Python facilitate to store numbers in these different number systems. If you want to declare a variable in binary representation, you can say 0b. If you are declaring a variable starting with 0b and assigning a value starting with 0b, Python will recognize you are going to provide a binary representation. You have to provide like a value either represented by 1 or 0. Right? You can have like a 1 0 1 1 1, any value you want, but you can have it could be like should be two digits. The octal representation, the notation for octal representation, 0 and O. If you provide 0 and O, Python will recognize the remaining values or remaining digits you provide in this variable declaration will be in octal representation. You can, in octal representation, like we saw in the table above, you can have any digit between 0 and 7. So here for a simplicity, I'm using all like 1 0 1 0 1 0. So the third variable I'm declaring as hexadecimal. The notation is OX for hexadecimal representation, and after OX the digits coming after OX will be recognized as digits from hexadecimal representation. So let's execute this, and let's execute these declarations. What they're going to deliver into variables M, N, and P. Okay, Even you provide the number in the representative number system, the value is stored as decimal internally in those variables, right? So if you try to print the value of m, provided binary value 1 0, which you know by the table above, binary value 1 0 is decimal 2, all right? And then in the octal system, the variable n, you provide 1 0. What you should expect? 1 0 in octal system, this column is octal. When you don't see the header, the value should be 8. Did we get it? Yes. And for the variable p, for the hexadecimal representation, we provide 1 0 again. 1 0 is the decimal number 16. We got the same as we expected. All these three, even you provided in different number representation, they will consider as integers. Now let's look at another conversion from a decimal value to binary. Previously we explored how you can define a variable in the number system representation. Now if you wanted to convert a value into a different number system, for example decimal to binary, we can call another built-in function called bin. If you pass the decimal value to bin function, it will create a representation of this value, a decimal value in binary. Same as the octal and hexadecimal, you can call OCT, oct, for octal, a decimal to octal conversion, and hex to convert decimal to hexadecimal. So let's see what is going to be assigned to M1, N1, and P1 variables. And let's explore the data types of those. You saw something interesting happen here. What we did was, we convert decimal value into binary. But you see the data type of each converted value is string. Here it's not having like a numeric representation, but a string representation of the binary digits of this number. Okay, so what it returned for M1 is 1 0, as we should expect, as we know above. And for N1 it gave like 0 or 1 0 for when you put value 8, and hexadecimal it gave 0x10. Those are like expected, nothing surprising. Now it will be your task when you are trying this out in your own time or in your own like environment. You can try out different numbers and play with it. So you will learn by doing that than listening to this video. All right. So the next representation I wanted to get you introduced to how is a complex number represented in Python. This will not be applicable to some ordinary Python applications, but if you are using Python for any physics or any advanced science related applications, probably you would like to know how you can represent complex numbers in Python, or how you can use complex numbers in Python. Python facilitate the declaration of complex numbers in the variable declaration. How we can do that? Before that, let's try to understand what is complex number for those who don't have a prior understanding. You can read more about it. This definition is not alone will not help you, I know. But a complex number we define as a number with two parts. One part of the complex number is real part, the other part is imaginary part. You can represent complex number in this Cartesian coordinate system. Each point of this Cartesian coordinate system will be called as a complex number. Each point will be having a component from the real axis as well as imaginary axis. So all the real numbers you are dealing in like day-to-day operations are on this line. Imaginary value is 0. Another useful information: complex numbers are subset. Imaginary numbers. Real numbers are subset of complex numbers. Okay. So if you wanted to construct a complex number, we need to have like a real value like a plus bi. So I stand for imaginary value. So the a and b are the values you need to provide, and those values will make a complex number. We traditionally call complex number, we denote by z or z. Here we define two complex numbers. So first variable is q. We assign 1 plus 2j. By now you know from this definition, 1 is your real part, 2 is your imaginary part, right? 2 units along imaginary axis towards positive side, 1 unit from the real axis towards positive side. That's what this q, a variable, hold that value. And the variable r will hold another value, 1 minus 2j. What does that mean? 1 unit towards your real axis, the positive side, 2 units towards the negative direction on the imaginary axis, should be towards downside of the imaginary axis on LIC shown on this plot, right? These are two different complex numbers, and then let's try to print them and then verify what are their types as well. When you print a complex number in the print statement q and r here, you will see it's surrounded by a parenthesis, so it says like 1 plus 2j. That is how it's going to print. And then the q and r, the data type of q and r, it called complex. So they consist like a different data type, right? So they are complex numbers. Okay, another useful thing, again, it comes the q and r, like any other Python variable, are objects. So you can access their real and imaginary parts of those variables, right? If you want to access their real and imaginary parts, you can call q.real, q.image, or photo imaginary parts. Let's see whether we get what we expected. As we expected, for q variable, we should get 1 as the real value, 2 as the imaginary value. All right. So then let's look at how we the variable data type can change. Like we already tried this out, but now we know the type function. We can verify whether this a actually changed its type. Previously we did not verify the type because we did not get introduced to the type function at that time. So let's verify in this change of value assignment from integer to like a floating point number, whether a made a change to its data type. Yes. So first declaration a was 3 and the type is int, and the second assignment to a is 3.14. You assigned later on the same code block executed at the same time. You assign 3.14, which is a floating point number, made the data type of a is a floating point number. So now a change its type with this. Okay. All right. So now we looked at in very detail how you can define a numeric data type, and we explored numeric data types with real numbers, complex numbers, integers, floating point, etc., and how we can define or declare them. So let's go to string data type now, and how let's explore how we can declare string variables and use them in our code. Again, like this is like kind of a basic overview. With more topics we're going to discuss in future lessons, we will add more content to this discussion. So we will get to know what are the other methods we can work with the numeric data types and string data types. So there will be a lot of applications of string data types we need to learn in your data science learning, or if you wanted to explore the machine learning and data science in your later stage of this learning. So you need to explore that. So let's look at how we can deal with string data types now. You can say, like, in first let's try to explore how we can convert a number to a string, right? So we define value a variable a and assign value 1 to a, which is an integer, you know, now, and then the type of a is integer, as you should expect that after you execute this line, right? And then if you wanted to convert this a to a string, you can use another built-in function in Python, which is called str. So this str function will convert a variable like numeric or any other data type variable into a string. If it is possible, the conversion is allowed, you can get that converted value to a string. So the type of a, we can a string, so I'm assigning that converted value to a underscore str, and later I will check what is the data type. Okay, so I'm assigning that variable to a str underscore type. Another useful thing, another side note I wanted to add here. So if you are building a Python code, especially for data science or machine learning or any other application, scientific computing, any application, make sure you use meaningful data variable names to your data. So don't try to use A, B like we had in above in this notebook. This is just to illustrate for education purpose, but if you are using for your application, make sure you give meaningful variable name, because this will increase the readability of your code as well. Okay, so that is like a side note, but it will be helpful in future when you're seeing through my code, as well as applying this knowledge to your work. Let's verify whether this A actually converted to string. Previously A was an integer, so A was an integer. Actually we didn't change A, but we changed that, we converted A to a string and assigned to a new variable. That's what we did. So the second variable we created, ASTR, is getting the type string. So we made the conversion by applying str function, built-in function. All right, so that's one way we can convert numbers to string. We already know how we can define string in the very first few code blocks, right? So you can define multi-line string, you can define single line string. So how you can define a string and then how you can add two strings together, we already saw this in print statement. If you provide strings comma separated, they will combine and make a one string when it is getting printed. But if you want to explicitly combine multiple strings together to make a one string out of it, you can use the plus sign or the addition operator. We will explore the operators in detail later time, but with regard to string, you can put plus sign or the addition operator to combine strings. So this will work as a concatenation operator. So now we have A is 1, A underscore type is type of A. That's what we two variables we created, and we also wanted to have the statement like value of f. Sorry, this should be A now. So value of A. Next we should print the value of A to concatenate. Remember, concatenation cannot happen string with a number, right? All variables to be used with the concatenation operator should be strings. Therefore this numeric value of A I need to convert to string explicitly. Therefore I'm using str function, and then I'm concatenating with another string A, and type of A is, okay, string value. I'm converting the type object to a string explicitly, and then the type is the type of A, return an object value, and then you can convert explicitly to a string. Remember I told you like string can convert any data types to string form. Then let's see the note, how we can print it. So if you print the concatenated string note, we should expect the same thing we had above with the comma separated strings in a print statement, right? So we get the output as we expected. So now let's look at how we can use the multiplication operator with string. What is going to happen? So can you imagine what is going to happen with the multiplication? We have a string called greeting, which had hello with exclamation at the end. What is going to happen if we multiply that string by 10? You know, like if you multiply any number by 10, the value will be multiplied by 10 numerically. But here is a string. What is going to happen? Just think, and let's try to execute and see what is going to happen. As a number multiplied by 10 will give you a value 10 times that of the value you originally had. Your string is replicated 10 times with the multiplication operator, right? You can say multiply by 5, it will have like hello 5 times. Multiply by 20, hello 20 times, right? So this is multiplication. This is what multiplication can do for a string. Then let's look at the escape characters. We already looked at those escape characters, tab and new line. Here I just wanted to bring this again under string section. If you wanted to make a new line character to separate your words or parts of your string into lines, so you can use that new line character. I'm not going to discuss because we've already discussed this before. And let's see the execution result. As we expected, we got the line breaks. Hello universe will be 2 line, and then let's learn the new line, and then the next line will be Python. You know, like that happened because of this new line character /n, right? So that will make a line break. Same as we observed earlier. So tab character will make you a tab separated string, right? So if you wanted to split your string with tabs, you can put a tab character in between. So you all know these two, and I will highly encourage you to try this out in your own with different strings, different formats, combination of new line and string. So here is an example how we can use new line and tab character together to make a table representation when your print output, right? So this is your print output will deliver to you. All right. So then let's look at string types in detail. Multiple different ways of representing strings. So multi-line strings you can define same as the comment. You can if you assign that to a variable, it will become a multi-line string, right? So here, like hello universe, let's learn Python. So they are in 4 different lines. So you can have printed as 4 different lines because the para is a variable, string variable, contain a string with as you input in your code, right? So when you press enter in on the IDE or code editor you use, so here is this code cell will become your code editor. It internally store this enter key press is a new line character. That's why if you see the para or the this variable how it's stored, you see at the beginning you have a new line character because after these triple quotes you are making a new line, and then hello new line, universe new line, let's learn new line, and Python new line, right? So before it comes to the end of the multi-line string. So you see the new line character appear in multiple places because the even you don't see it, your enter pressing the enter key will add new line to this string, right? So that is how you can define multi-line string. A raw string or like the R string, you can be very useful in this application. How you can define a path, especially like a Windows path. We will let's first execute these lines and get to know by experience, right? So think you have a folder. That folder is C flower tulip, right? So that is the in C drive you have a folder named flower. Inside that you have a subfolder named tulip. So that's what you have. If you wanted to print that path, or first you need to assign that path as a string to a variable named folder path, and if you want to print, you can simply print it. Can you? No, there is a problem. What is going to happen here? We know previously new line character is considered as a character representation of a line break. Same as that, the /f will be the form feed character, will create a line break here. We know very well the /t will be the tab character. What happened here, when you send this string into the print statement, it will convert, or when you assign these characters, it will convert to tab character and form feed character internally. So here you have the folder path, but you did not get what you expected to get print here, right? You are missing some characters and some weird manipulation happened to your string. So how to overcome that? So we have to use the escape sequence. So in Python, if you are using such special character or the special representation, if you wanted to avoid them identified as their special representation, you can have additional slash character to avoid such a misrepresentation. If you do this, you will get what you expected. You expected to have this in your print statement, you got it. But internally, it store as like double slash instead of single slash here, right? To avoid such a scenario, if you don't want to have this double slash to avoid the escape character, you can also create a raw string in Python. So the literal is this. So you have to have R before you open your quote to define your string or declare your string to your variable. So here, if you have a R string with this notation, you can simply define your string or like put your string without escape sequence. You can have this special representation, but they will consider as a raw representation. They will ignore all the special representation you have in this string, but internally it will store as double slash with escape sequence. But you don't need to, when you input or when you hard code these values in your code, you don't need to provide double slash or the escape sequence if you use R string. All right, so you can either use capital R or simple R. That does not make a difference here. So you can choose either one. I would use simple R. All right, so now let's look at the byte string. We already explored one attempt. You can convert a numeric value to a byte string, right? To illustrate or showcase you with variable is also like an object, so you can call that function to convert your variable into a byte string. Here, this byte string will represent an emoji value. So I copied this byte string from internet. So when you define a byte string, same as the R string, you have to say not R here, should put B before you define or before you declare your string variable, before the quote, single quote or double quote, either one you can use for string definition. You have to put B before that, right? So you see how we define the byte string. So within the quotes, you have the byte value as a string. So if you wanted to print this, the value assigned to num bytes, so we can see the print statement will print the byte string. And if you wanted to know decode this byte string and to get the actual Unicode value of this emoji or to display this emoji, you can call this string variable dot decode. Okay, so decode will give you the actual value stored by this byte string. So you see how it printed as the byte string and what is going to return when you decode that value, right? So when you decode this byte string, you will get the symbol of a computer in emoji. So that's what this byte string represent to you, to computer. All right, so we looked at many things about the strings, and topic of strings will be covered in a separate lesson, but for now what I'm trying to cover here, the very basic stuff for you to get started with programming in Python. But still you will see, I will show you some activities and some demonstration what you can do with the things you learned so far. And so you will get started gradually by advanced concept later or intermediate concepts later in this course. So let's see how we can modify a string dynamically. Previously, what we did was we concatenated a string by either plus sign or the addition operator, or just simply passing multiple string to the print statement. We can also make it more systematic by using the format function in string, right? Let's see how it works. In very high level, format function is something like a template. You can have placeholders to insert dynamic values. So if you have like a variable, it can change while the execution. That value can come to a placeholder you define in this string. You can have those the variables under this format function, and then let's see how it works now. So this is your string you wanted to either print or to use later in this code. So these curly brackets, open and close curly brackets, represent a placeholder. Here you have two placeholders. How Python know what are the values those placeholders should take? Those are the values you are giving as parameters to the format function. So remember, this string, as it defined, even it is not assigned to a variable before, this will consider as an object. Okay, so at the object string, this string object has a function named format as the function we talked earlier. So this format function we can call and then pass the parameter b, which is our variable value, and type of b will return the type of b as the second parameter. So those two parameters will take into these places, right? So in first place will take the first value, second place will take the second value. So after you execute, you will see what is the value of b and what is the type of b. Now let's do some modification. If you wanted to print the value with the fixed decimal places, sometimes when we display value, we need to have a special representation of number of decimal places, right? You need to you require to have 2 decimal places. Even no matter like how many decimal places you had in this number, you only need 2. So how you can do this in this representation? So how you can do this is you can put your inside the placeholder, you can put this colon and then put dot 2f. So this dot 2 will stand for the 2 decimal places and f stand for the floating point numbers. You are representing this input value to this placeholder as a floating point number with 2 decimal points. So that's what this 2 stands for. If you wanted to have a 3 decimal points, you can simply make it 3 decimal points. Right? I will leave it like as 3 decimal points. And then type of b, you don't need to do any modification here. It will be same as before. You will see that. So let's see okay, before that let's go to the third option. So now if you want to create a string and assign a value when using, what you can do is you can create your formatted string or the string with your placeholders and assign that to a variable even before calling this format function. Right? You don't need to call format function before you assign to a variable or before you print. You can store your string with this formatting of the placeholders. So later you can call that variable dot, this is the string variable, of course it should have format function, then pass the parameters as it should go into this placeholders when it execute or when it print. So let's see how these 3 print statements display on the screen after your execution. As expected, first one printed the value and its type, so with the number of decimal points as we provided. The second option, we limited number of decimal points to 3 and therefore we get 3.142 as we expected. The third option, nothing surprising here, but what we wanted to try out, first create the variable with placeholders and then call the format function while we are making it a print. So it worked. This is how you can use the format function to dynamically assign values to a string, either you to print or to use later in your code. So you can do the same thing with another method they call f strings. Here also you can either use capital F or small case f, but you have to have this f character before defining your string, before you are opening your double quote or single quote to define your string. So those f strings don't require you to call the function like format, but you can put the placeholder within the function, within the string itself. How we can do that? So the same thing, let's try to do the same thing as we did above. So we have two values. So one is the value of b and the second variable is the type of b. We hold those two values. And then if you wanted to use the f string, so you open the f string by putting f and then open square bracket and rest of the thing will be the string. you can say value of b equal within the placeholder. You just need to provide the variable name as it appear on your script. So the variable name is b, so this b is going to appear within your curly brackets inside the placeholder. And then you can also have like code execution within the code block. This is this curly brackets. You can have like simple Python expressions like the type b. We will learn what are the expression and statements later, but this type b is called as an expression. You can have like some addition of two numbers, subtraction, or any operations within. So whatever this expression return to this place is going to be the value. It's going to be on this placeholder. Right here the type b will execute and assign the value to this placeholder. So they should technically should print the same thing as you had in the previous code cell. And now let's see how we can do with the fixed decimal places, same as we did with the format. So if a value of b is, you have to print with 2 decimal places as a floating point number. Here I have to provide what is the variable should come here before the colon, right? In previous attempt we did not have the variable name, but here we have to explicitly provide the variable name. And then you have to provide what is the format you expected. So we will learn few more things about this formattings down in this notebook. But here we just need to execute this and see what is going to print us. As expected, the first one you printed the value as it is, and the second one with the formatting we get the 3.14 as we expected with 2 decimal places. Okay, so nothing surprising, no changes than what we get above. But there are 2 different ways you can represent a string, like you can dynamically change a string by variable values, putting variable values into a string. All right, so this is another interesting thing and very useful thing for many of you working with data. In our data work, sometimes we get very large numbers. When we represent those numbers on screen, for us to understand how big is, or if you wanted to put into a display on a screen, we better have some 1000 separators to know, or like what is the number actually represent, right? We want to know whether this number is in millions or billions or trillions or hundreds of thousands, right? So if you have a number like this, it's very hard to find that the range, or find the estimate the value of this number, how big it is, just by looking at it, right? What you need to do is you need to count how many zeros to get that one. So if you put commas as a comma separated value, it's very easy. Now you can easily read it as 10 million, right? Without it, you see how difficult it is. But Python won't allow you to put commas as you see in Excel or in any other similar platforms. You are not allowed to use commas. Comma means something else in Python, right? So if you use this these big numbers and you can print them, you can assign, there's no problem, but it decreases the readability of your code and the values you display. So let's explore how we can improve that. In your code, when you hard code values, even you don't allow you to comma for 1000 separator, you can use underscore. That is allowed, right? So in Python, underscore is allowed to be used as 1000 separators for numeric variables when you assign values to numeric variables, right? So this is allowed, and this will create a variable a and assign value 10 million. You can also read it is 10 million. Now see how easy to read the same number as the previous cell, but it's more easier to read, right, as the 10 million. The second variable assign 10 million 2000 as the value to variable b. So you have both comma separation is happen with the underscore. Okay, let's see what is going to print. Even you input the number with comma separated values, Python won't recognize, or Python won't store those comma separation. It will simply store as a number. nothing surprising. That is what Python does. It will not record this comma separation because that's not part of the integer variable you create. If you were to keep this comma separation in your print statement, you have to apply that in your formatted string. How you can do that? Like we already explored how you can limit how many decimal places in a floating point number. Here you can instruct your formatted string or like the f string, add comma separation by putting comma after the colon. So you have to provide a variable name, then colon, this is what required, and then you can provide comma as the next character in this formatted string, and this notation will add comma separation to your big number. If you still wanted to keep underscore as your comma separation in your output, instead of comma you can put underscore. That's not a problem at all. Let's see what is going to be the output. So now the output is more clear, much prettier, and more readable, right? Your input with underscore comma separated. Here I purposefully did not do the comma separation in the input, but did the same thing in the output just to showcase even you provide a number like this, even you get a number from your calculation, a big number, you can still print to output by changing the format string. So now let's see like one more modification just for out of the curiosity. You're probably interested what happened if you put dash. It's nothing going to happen, right? What happened if you put something else? So if you wanted to put plus, nothing is going to happen. They have like different meanings. So you can put comma and underscore as thousand separators, right? So I'm not going to go into very detail about this format string. What does that thousand, this plus symbol mean, minus symbol mean, etc. It would be beneficial for you to explore that. Unless I'm going to cover this in a later time in a different lesson. But it would be beneficial for you to explore this different ways of formatting your string to make your output prettier, output more readable, more useful to your user, right? And another note I wanted to make, try to use this f string than any other method we use if you wanted to make a dynamic print statement, like if you wanted to embed the variable into a string, embed another numeric variable or result of a calculation or something into a string, I would highly encourage you to use the f string. All right. So now let's revisit our decimal places again. This is the precision, the maximum precision the pi can take in this computer as Python stores it. This is maximum precision Python stores it. And let's see how it prints without any formatting changes and with 5 decimal places and 2 decimal places. Okay, I don't need to re-explain. We explained this. The first one it will give you the value as you provided, and the second one limited by 5 decimal places. Third one is 2 decimal places, right? So, as we expected. All right, and then let's go to another interesting topic: displaying numbers with leading zeros in your format string. Okay, if you wanted to display numbers aligned, if you are displaying a table, right? So if you have different digits, number of digits in each value, you need to align them on like right align, left align. You can do this in this format string as well. But here I'm going to show you how you can display a number with 0 leading spaces, right? So the first one, A is 1015. I wanted to display as a 6-digit number. If you have less digits in this number than 6 digits, those values will be replaced by 0. That's what I'm going to do by adding a colon, colon, then after that you have 0, and 6 stand for how many places, how many digits you expect in this number. Okay, the second line, instead of 0, I'm going to put empty values or spaces. You can have space and 6, or you can simply have 6. Both will do the same. I'm going to have like 3 numbers here, and both B will be the same thing. I just want to illustrate this having space or without space does the same. And the third one, I'm having 3-digit number instead of 4-digit above, and still I'm going to do align with 6-digit places. Okay, see how it worked. So first one got two leading zeros, because we added leading zero. Second one you get two empty spaces. Third one, even you say empty spaces, you get empty spaces, because this is 6 stand for, we need the six digits in this number. That's what we expect. By default it right aligned, right? So and then C, you have like 3 digits in the number, but it aligned to right, and replace the leftmost 3 digits by spaces. All right, so now you can do the same thing for the floating point numbers. So see, like the first floating point number, you have 1050, and then with the 2 decimal points, 7.75. The second one you have 210 with 3 decimal points. Both we need to print and align the print with 2 decimal points, and also we wanted to align those decimal points. So for that we will do 10.2, this addition of 10.2 your formatting string will tell Python, okay, how the whole numbers, the 10 digits before the decimal point, that's what the expectation, and 2 digits for the decimal point. So let's see how it does. Okay, so it perfectly aligns. So it expects 10 digits, right, in total, and then 2 decimal points, and it displays as a floating point number, nicely aligned, like right aligned, and your decimal numbers are there. You can have only 2 decimal points, even you have 3 decimal points in this number. All right, so that's about displaying the numbers and aligning them for a nice visual purpose. So now let's look at how we can represent percentages. So I accidentally executed, but you will see this. If you want to display a percentage value, say like if you wanted to display a percentage as like 3%, one way is simply you can add a percentage symbol to your string. If your variable say the percentage value out of 100, so this represent 3% percent, and then you can simply add a percentage symbol, and it will simply display 3%. If you want to display it as a floating point number, here you don't see any floating point digits here, like in no decimal places, you can say display the value with 2 floating decimal places. And then the next cell, if your value is given a fractional value, 3% can represented by 0.03 out of 1, not out of 100, right? If to get the percentage, you need to multiply this value by 100. So please understand that sometimes I have seen people got confused with this percentage with the fraction, and when they create dashboards made huge mistakes with that, right? So this is a percentage, like 3% represented as a fraction, it's 0.03. If you wanted to display that value with a format string, you can simply say the percentage symbol after colon in your format string. So remember, this percentage is now at the inside the curly brackets, right? And then this format string will generate a percentage out of this fractional value, right? If you wanted to make it more clear, I will put 0 here, and fractional value, and create a 3% and display as 3%. If you wanted to limit how many decimal places, again this like same as the floating point number, this percentage, we can also say 0.2, how many decimal points you are expected. You can say it with the two decimal places or 3 decimal places by this notation, right? So this stand for your fractional value should be represented as a percentage value, should add percentage symbol at the end, and as well as should display with 2 decimal places. Let's see whether we can get that as expected. Okay, we got it. First attempt, we get 3% out of when we provided 0.03, it got calculated the percentage value and got 3%, but excess decimal places, like many decimal places, 5 decimal places, 6 decimal places. But if second attempt we limited how many decimal places, we get 3.00. Okay, so now we can examine how we can in little bit detail than what we did before, how we can work with numeric data. When we discuss about data types, we know like we can have data numeric data as integers, floating point numbers. Even within floating point numbers, you can have like float, double, integers. You can have byte, small int, integer, big int, like many different variations of integers, right? But we can call all of them as integers. And also we learn about different number systems, right? The base 10 like integers, right? So in the decimal system, so that's how we commonly use numbers, right? A is 10, that means the number is 10. So we can print, we don't need to go through this again, we did this previously. And we also did the binary, octal and hexadecimal. We covered this previously. You can represent that integers, and then you can convert decimal values to different number systems. Binary number 16, here I'm picking one value 16. I wanted to convert this 16 into binary, so this is the binary representation of 16, and this is the octal representation of 16, right? And then hexadecimal representation of 16 we looked at earlier, but other two you can see I used the 16 to convert 3 different number systems. Okay, so this also we covered previously. If you wanted to convert integer any number, say like the b here, so b is a binary. So remember we discovered this b is now like in binary representation, all right? And this representation we need to convert to integer. So how we can do that is by calling the built-in function int. So we will get to know about this int function again, about number conversion. So if you wanted to convert your binary representation of this number to integer, you have to provide what is your number, and you have to provide what is the base or the number system you use, right? So your 2 is stand for binary. This b is in binary form. You convert into integer, you will get the value 16. And same as that, if you wanted to convert the value 8, so the 8 means the c is the 16 converted into octal, and the 8 means the octal. So if you call the int function with the value in octal, and you say the value is in octal, it will convert to the integer value. Same as the hexadecimal, 16 stand for hexadecimal or the base, and you have to provide the value in hexadecimal, a string representation of hexadecimal, this one, and you can convert this to integer value. So let's see what it gives us. Like they all give 16 as we expected above. Okay, so now let's see like the floating point numbers. We again we already went through this, therefore I don't want to explain it again to you. So we can define a floating point number, and we can get the type of floating point numbers. A numeric data type conversion, this will be like another important thing, the data type conversion. Some data types are allowed to convert, some data types are not. Some data type conversion can occur data losses because like if you have a floating point number, if you convert a floating point number with decimal places into integer, you are going to drop all the decimal places, right? Therefore you are not representing the same number. But if you are converting integer to a floating point number, you are not having any loss of value. So let's see how we can convert integer to float. B is an integer. The data type conversion is happening with the function float, another built-in function. Integer value provided to float function will generate a floating point number, right? So let's verify this. Integer value b, when we convert into float, b float will become 2.0, and we verified initially it was integer, and like b is in integer, like type of b is integer, type of b float is a float. We converted the value of b into a floating point value. So the same as that, we can convert floating point number to integer, like I said. So initially 3.142 is a floating point number, type is float, and then converted into integer, that called b int, but we lost the decimal places like 0.142. The value of b int is 3. You simply truncated all the decimal places. So this is not something we expected to do to happen in our code in many times, right? So this conversion, you need to be very careful about such a conversion with losses. You can also convert like a boolean value, like true false value, to integer. If you pass true false value to an integer, so what you expect, true will be converted to 1 in integer, false will convert it to 0 in integer. Let's see what we get here. All right, so as expected, true converted to 1, false converted to 0. And the data types, type of b initially was like boolean, and when we converted to integer, that become integer, same as the c, right? So you see the data type conversion happened properly. This could be some useful conversion if you wanted to count something, but in Python, true is always seen as 1 and false is seen as 0. Convert integer to a boolean can also be done. You can convert a as 1 is an integer number. If you convert into boolean, it will become a boolean value, so it should be true, and 0 should be false. So let's see this. All right, so a is 1 become boolean true, b is 0 become boolean false, int become boolean. Okay, so now we can see how we can convert integer to a boolean number. Not integer not is 1 or like greater than 1, right? So let's see what happened to a is 5. What happened if we converted a to boolean now? We can see like the output, and same as that, b is not 0 now, b is -5. What happened if a negative number converted to boolean? Let's be curious and try to execute and find out what is going to be the result. What happened? Both became true. What this is going to tell us, if an integer value is 0, if you converted that value to a boolean, it will become false. Regardless of whether it's negative or positive, your integer value will become boolean true, right? 0 always become boolean false, and non-zero values in integer number, regardless of positive or negative, will become boolean true. All right, so we know now more details about the numbers and data type conversions. Let's do another one. Convert floating point number to boolean. A is 1.0, which is a floating point number, and b is 0.0, which is also a floating point number. So let's see what it is going to deliver to us. As we expected, regardless of whether it's a float or integer, so 1 is always true and 0 is false. So you see like the 0.0 converted to false and 1.0 converted to true, right? The float became bool by this bool function conversion. Okay, so now if you wanted to convert a number to boolean, you know that. So now you can convert any number to boolean value. So we already explored that. This is kind of a duplicate. All right, so now let's try to do some more conversion operations. If you wanted to convert a string, for some situations we get data, numeric data, as string representations. When we extract data from a different source, when we read a file, or when we accept a user input, you will see one of the activity I'm going to give you with this notebook. So your user input will be taken into the memory as a string. So you cannot, if you wanted to add two numbers, you ask a user a first number and then ask a second number. If you want to add them together, you cannot simply add them. If you add them, it will be a string concatenation. If you want to numerically add them, you first need to convert them to numbers. So to convert string representation of numbers to integers, you can still use the int function like you did above. This 100 is a string value, string representation of the number 100. We assign to a. You can convert a to a int by using the int function. Right? The a int will store a number 100. So let's verify this by executing cell, and then you see value of a is 100, that is the string 100, and type of a is string. And then when you convert, value of a int is also 100, but now it's a numeric value, type is int. Same as that, if you have a representation of floating point numbers, can we do this conversion? Let's try. It is not allowed. What is the error message say? A value error, invalid literal for int. Int won't accept a string representation with decimal points to convert, right? So this you need to be careful in this conversion. All right. This will lead us to another observation of Python errors. In this notebook, if in notebook environment, if you get error, you will get the error message right underneath your executed code cell. In a Python error message typically will tell you what type of error it is. This is a value error, and it will also give you a trace back and also point to the line where the error occur in your code, right? So this will be a useful thing if you wanted to diagnose. We will discuss about errors and how to handle errors in detail in a lesson afterward. But for now, you should expect these kind of errors, and you probably need to have some idea how to know where this error happened, and you probably need to diagnose this error by this error description, right? One suggestion for you is to, if you get such an error, you can do a simple Google search and find out more details about this error, or you can go to Python documentation and read about these value errors. All right, let's move forward with the other conversions. Now let's see an integer representation of a number as a string. So in a string representation of an integer number, can we convert into a float? Let's see. That is allowed. There's nothing is going to lose here. So 100 is an integer representation, will be converted into 100.0 as a floating point number, and it became float. Previously it was 100 as a string, and then the type is string. Okay, so now let's do the same thing for a floating point number, string representation of a floating point number. As expected, we get string representation of a floating point number 3.142. we get a floating point number stored as a floating point number after we apply the float function, the built-in function in Python. Okay, and then let's look at number to string conversion. If you have a number and if you wanted to convert this number to a string, so this will also be a useful function in Python. If you wanted to display or send your values to a different system, if you wanted to synthesize an output for an API, you probably need to do this number to string conversion, right? So in this case, we have two numbers. A is an integer, B is a floating point number. Applying the built-in function str or the string conversion function in Python, if you pass those numbers as parameters, they can convert into string values, right? So a is an integer, a is string, as a is in underscore str is a variable storing a string variable, right? So let's see how it's going to happen here. So a str is 100, and the type of a str is string, same as the b str, which converted the floating point number into a string and store as a string variable. All right. So let's see, this is an exercise. If I would deliver this as a live class, I would give the class, but You can also try it out your own, but you have the answer. So convert decimal to binary uh, by providing any user input, right? So like I said earlier, user input always taken as a string value. You need to convert this to a decimal point, this like number first, before you do any numeric operation, right? So let's see what this line is going to do us. And first one, get user input and ask a user to provide a decimal number, and then that number store a number in string representation of the number stored as number underscore string variable. And now that variable representation, string representation of that number, you need to convert to integer, and then that integer value you can display. So let's see how it works. It prompts you to provide a number. I will say 1 2 3. If you provide a floating point number, it will probably give you an error. So let's first do that and let's get the error. The same error we got earlier. We gave a floating point number, integer cannot do this operation and throws an one value error. So let's see, give a proper number 1 2 3. It worked as expected, took the 1 2 3 as a string and then converted to integer and then displayed the integer value out. Okay. Then let's look at the operators. The operators are a very useful thing in any programming language because you can store data. That's one part of your programming, but you need to do work with your data and operate, right? So you probably need to add numbers, subtract numbers. We already looked at concatenating strings. The many operations you need to do in order to get some tasks done from a computer, right? So let's first explore arithmetic operators. So arithmetic operators are like division, subtraction, addition, multiplication, like that. So addition, and let's first look at addition and subtraction. Before that, I'm going to define or declare two variables x and y. X is 7 and y is 3. Both are integers. By now you should know the definitions, right? When we looked at the addition, let's first look at the addition. I'm going to add x to y with this addition operator and assign the value to z or z variable, new variable I'm creating with this addition. And then I'm going to display the value. Before that, I'm going to use the f string format to show the what is x and what is y for visual purpose. Okay, so this print statement printed x is 7, y is 3, and then the last print statement show x plus y is 10. Okay, pay attention to the print notations and try to modify that or try to make your own print statement to get an output you would like to show your user. Same as that addition, let's look at the subtract. So the subtract, you're all familiar with the symbol. You can subtract y from x and then the value is 4, right? 7 minus 3, that's what we expected, is 4. So now let's look at how we can apply this addition to string concatenation. Again, like we did this before, and just to complete this section, I wanted to have this execution. We had two strings, hello and friend. If we simply add them together, a plus b will become hello friend. No spaces, nothing, just concatenate two strings together. Okay, so there's a typo here, the multiplication. So the multiplication and division work same as the addition and subtraction, but the operation is different, of course. So now your z is, or z will be x multiplied by y. 7 times 3 is 21 as we expected. You can see that in action. Okay, we also looked at it earlier, what if we multiply string with a number. So you can replicate your string 10 times if you multiply by 10, right? So this already you looked at earlier. So now let's look at the division. If you divide 7 by 3, what do you find? You get like 2.33. So 7 divided by 3 is this value. So the division operator is this. In Python, we can also have an integer division, or we call like floor division. You can use double slash, okay, the 2 times the division symbol we saw earlier. If you have this operator, it will do an integer division, so means you will lose the fractions, or the decimal places. So let's see what it's going to deliver you. The value is 2, so 2 integer numbers divided, and then it will also return integer number. You will lose all the decimal points. This is like we call floor division. So modulus operator will give you the remainder of when you divide x by y, what is the remainder? Okay. So remainder is 1. So what these two together can tell us? 7 divided by 3 will give you, like, the whole number is 2. So you have, and the remainder is 1. Right? So you have like, in other way you can say 3 times 2 plus 1 will be 7. Right? So the modulus operator, integer division, or the floor division will also be useful in some programming work. So therefore pay attention to the operation, and I highly encourage you to practice. Practice is the only way you can learn a programming language, not by listening to a video or watching a tutorial, but you just need to practice in your own time. The exponent function is also like a different in Python than some other programming languages. Therefore, if you are familiar with any other programming language, pay attention to this. Exponent represented by double asterisks, or like the you saw this as a multiplication operator. You have like double asterisk or double multiplication operator, you can say, as the exponent. In some programming languages, I can make like a comment here, x, y. So this is how you see. If you wanted to say 2 to the power 3, this is how you represent. But in Python, how you represent in Python is x, 2 asterisks, and y. If you want to represent 2 to the power 3, this is how you represent. Okay, let's see what could be the output. So 7, 3. So 7 times the 7 to the power of 3 is 343, right? So this is what this operator does. So the remaining operators are assignment operators. We looked at arithmetic operators. So the assignment operators are, assign value. We already using this for a long time now. So this assignment operator, you assign a value to a variable. If you want to assign okay, like this, a result of an expression to a variable, you can do that with assignment operator. But if you want to assign a value to a variable, also you need to add those two variables together and assign to the same variable, right? So here what we wanted to do is we wanted to add x and y together and assign this value back to x. So this you can do like this. Another way you can do this, x equals x plus y. This you can do in a very short form by applying this operator. So let's see if that is going to be true. See, like this is going to be 10, and the operator is this. You don't need to have like another location, like the representation of x in your expression. And same as that, you can have x minus y. If you say minus assignment operator, and then it will x minus y assign back to x. Okay, so now let's look at comparison operators, or the logical operators you can call. We define 3 variables. A is 2, B is 3, C is 2. And if you wanted to check any two values of the variables are equal, you can say equal or the equal operator. So two equal signs, A, B, and C values. And then if you say A equal B, is it true? A is 2, B is 3. They are not equal, so the result is expected as false. These operators will return true or false values or Boolean values as the output, right? So A equal C, A is 2, B is 2. So this should return true. That's obvious. Same as the equal, so we should have a not equal, the opposite meaning of it, right? If you wanted to compare two numbers and say whether they are not equal, if they are equal, the answer should be false. To not equal, if they are actually not equal, the answer should be true. So let's see how it's going to work. We know A is 2, B is 3. A not equal B, true. A and C are both 2, right? They are equal. So to the not equal operator, that is false because they are equal. Now let's look at the greater than or less than. So greater than, less than, also very useful thing in as a comparison operator in Python in many different places. Therefore pay attention to it. If you don't understand, read more about it and practice yourself and learn it thoroughly. So less than, greater than, we all know. So what we are asking Python question whether A is greater than B. This is how we ask. What should get? A is 2, B is 3. A is actually less than B. Therefore, the answer for this question should be false. We are asking A is greater than C in this line. A and B are equal. They cannot be the one greater than the other. Therefore, the answer is false. So here we are asking a different question. A greater than or equal B. Can it be true? A greater than B? No. Either A is equal to B? No. Both should be not true, so therefore false. This one, we are asking Python whether A is greater than or equal to C. A is, of course, then A is not greater than C. That is true, but A is equal to C. It's a different question than this question, right? So therefore, A is equal to C, that satisfied the condition. That makes it true. So pay attention to the line and the answer you expect, right? This is true, but this is not. This is true because this is equal. A and C are equal. Same thing you can apply for the less than. You can execute this by yourself. You can see A is less than B, A is less than C. Both answers are, first answer is true. A is 2, B is 3. Of course, A is less than B. A is less than C. It's not true because A and C are equal. You cannot say A is less than C, but you can say A is less than or equal to C. A and C are the same. A is less than or equal to B. Of course, it's true. A is less than or less than B, and then A is less than or equal to B will be true as well. Let's see some other logical operations. You can also have like this as expressions. So we call like expressions. These operations or comparisons or these logical operations we call expressions. Anything like in Python, like you can think of like these expressions make statements. So these logical expressions you can assign to a variable. So that will store like a true, false, or binary Boolean value. So these are like 2 greater than 10, 2 less than 10, 2 greater than 5, 2 greater than 0. You should expect false, true, true here, false here, true here, right? So let's see what A and B and C are storing. So true, false, true, as we expected. What you wanted to get as the negation of this logical expression, right? So this logical expression will return you true, but if you apply a negation, means you are reversing the logical expression what it returns, right? If it returns true, you want to make it false. If it returns false, you want to make it true. So that negation, you can use the not word as the operator in Python. If you having like a variable named D, you are creating a variable named D with negating the result of A, right? So not A is true, not A will make the result as false. So D should expect result false. A is true, not A is false. All right. And also you can use AND operator in Python as the word and. Remember, these are case sensitive. You cannot have not in any other case, right? So it should be small case, not small case, and are operators and reserved words. You cannot use them into as a variable name or any other place except comments in Python. Okay. And operator, you have to check your logic gate. So I will have a slide in the lesson. You have to go back and check the slides about the logic gates if you wanted to review your this section with your understanding. So A and B, what simply it does is, if A is true and B is true, only if A and B both are true, your result will be true. Okay. So here A is true in our case, B is false. So is A and B are true? No, the result should be false. But A and C are true. What should return here is true. Let's see whether it as we expect. A is true, B is false, C is true. A and B, because B is false, the result of AND operator is false. A and C is true because result of AND operator, both A and C are true, and then result is true. Now let's see how this actually works. That as a truth table, we can reconstruct the truth table we had in the slides in this Python notebook. True and true is always true. True and false is false. False and true is false. False and false is false. This is the truth table you can get for the AND operator. Let's look at the OR operator. So to be to return true for OR operator, either A or B should be true. If A is true, B is false, it should return true. Let's see how it's going to happen here. A is true, B is false, C is true. Here I wanted to make it O, so it's a typo. Let's make it corrected. So A or B should be true because A is true, even B is false. A or C, both A and C are true. Either is true will make the result is true. This is true, right? So this is what you expect for the O operator. And then we can reconstruct the truth table. True or true is always true. True or false, always true. False or true, always true. False or false, always false. Okay. So this is this logical operations and, or, less than, greater than. So these are very useful in building logic in Python. So not limited to data science, analytics, or machine learning. In any Python application, you should know this very well, how we can apply logical operations, right? This will be very useful for when you construct conditional statements, loops, and some other logical flows in your program code, right? Therefore, try to practice and be familiar with these logical operations very much. So another operator types is bitwise operators. So we can have like a not, that's a bitwise operator. If we have like a binary representation of a number, what it does is it will negate all the binary values. So we can execute this and visualize. So number 10 is our variable assigned number 10. So this is the binary representation of number 10. All right. If you apply this not by bitwise not operator, it will flip all the binary values into a like different number. So here, if you flip these numbers, so this is the binary representation of positive 10, it will make a binary representation of negative 11, right, with the negative sign. So then you can apply left shift. So it will shift your binary pattern into like towards left side by one place. So this is why you are shifting by one. And you can do the right shift. you are shifting your binary pattern by a 1. You can provide any number, how many positions you need to shift, you can provide, right? And also you can have a bitwise AND operator. So the bitwise AND operator, if you have a and b, two decimal numbers, and you can convert into a binary, and then you can apply an operator. You can say 0 0 0 1 0 0 0 0 0 1 1 with AND operator. You are applying AND operator by bits. 1 and 1 is 1, so that makes you the if you apply the a and b bitwise AND operator, your result will be 8. That is the final representation of your bitwise AND operator. And then if you apply bitwise OR operator, you can also see the same way. You can say 0 0 or 0 0 1 or 0 is 0 here. So let me see, this is a typo, I should not get this. Let's execute again. 1 or 0 is 1, and that's the OR operator. 0 or 1 is 1, 1 and 1 or 1 is 1. So we apply OR operator across these two binary representation by bit level and construct a number with the result of OR operation. So A or B, when you apply this to those two numbers, your result will be 14 in decimal, but the binary pattern will be this. Okay, I hope it is clear to you. If not, try to examine this output thoroughly and then try to find it out how the OR operation applied and how AND operation applied in bit level. Go like a column of these bit locations. Same as that XOR. XOR is another gate in Python, in electronics also. Here what it happen is, if you have two numbers, both are 1, your result will be 0, right? So instead of like O, if you have both values are 1, your result will be 1. In XOR, if both values are 1 or both values are 0, in both cases result will be 0, right? So here you have like 0 0 is 0, 1 0 is 1, 0 1 is 1, 1 1 makes 0. If you apply XOR gate, this is the symbol for XOR in Python, and it will make you the number not 40. Let's execute this. XOR at 16. Okay, so this is how the result is 6 and the binary representation is this. So 10 binary representation is this, 12 binary representation is this, and apply XOR in bit level. So 0 0 is 0, 1 0 is 1, 0 1 is 1, and 0 1 1 is 0 is not represented here, but it will be 0, right? So you get 6 as the result for XOR. All right, so this is the end of the long notebook we went through to learn basic Python syntax, or not basic syntax, but the variables, data types, and operators, to build up your vocabulary for you to prepare learning Python in the coming lessons, right? From here onward, you can catch up with the Python syntax, how you can apply these learning to make more complex codes. So in the next short lesson, I will walk you through some activities or demonstrations, how you can apply this learning to solve some real problems, small problems. It's not very complicated ones, but I will explain the problem and apply all the learning coming from this notebook to solve them in writing Python codes. All right, I hope you enjoyed the lesson, and it's too long, I know, but let's try to explore the Python programming language and be better at Python programming. See you in the next lesson.